So thank you for coming for my talk on travel routers. This is something that I just found very exciting to work on. So my name is Mikhail Sosonkin. I'm a Director of Research and Data at Synac. And Synac is a company that leverages the crowd to find vulnerabilities in our clients. So if you like discovering vulnerabilities, if you like hacking, this is something that you might want to try out because it's sort of a way to do real-world vulnerability discovery and get paid to do it. So in the process of doing that, we also work on a lot of IoT devices, and I had a problem. I found myself to be a digital nomad for a while, and I was sort of moving around from an Airbnb to a cafe, and I had to connect all my devices like laptops, phones, my wife's laptop and her phones as well, and it became really annoying to do that. So I was trying to find something that would solve this problem for me. And so this was the motivation for discovering a whole lot of a section of devices that I did not know existed before this, called the travel routers. In fact, I have one right here. This is about the size of this device. There are tons of them out there. I picked this Hutu TravelMate because it is very reasonably priced. There are a whole bunch of reviews out there, and people say that it is actually good for you. It provides some security, it's very convenient to use, etc., etc., etc. And I figured, okay, I'll try it out. So I bought one. It was really useful because I was able to have all my devices connected to it as using Wi-Fi, and then I would just connect it to the cafe network, the cafe Wi-Fi, and it would sort of just bridge the two together. It's small, good for travel, has a battery pack, never catches fire, and it sort of gives you a little layer of protection. I felt a little bit of warm and cozy because I was connecting to my own little network using network address translation. So I thought, well, this is interesting. I like to hack things. Does it actually make me secure, or worse, does it make me less secure? And so I started doing some analysis. First thing I did, of course, network scan, see what services are available. I wasn't surprised to find that HTTP port 80 was open, and so this is for the admin interface. However, when I actually looked at the admin interface, I found that it had two services responding to me. One was light HTTPD, which is very popular, and I was very familiar with that. But the other one was called VS HTTPD. I was a little bit confused for a while. I mean, clearly there's some sort of proxying going on in the background, but what is this service? So I went out to Shodan, because that's what you would do when you are curious about something, and I searched for it. I found a few devices, not many of them are out there. I would expect that a lot of them are actually hidden behind private networks, so you wouldn't be able to see them. But there are still a few of them that kind of come up once in a while. Primarily in the area of Asia, so Japan, China. I didn't find any North Korea, but there were some Taiwan devices. So I knew they were out there somewhere, and there was some importance to them. Then I kind of turned on the device itself, and I decided to start reverse engineering it. First, I downloaded the firmware from the Hutu main page, and that was easy. You just click download. It turned out to be a raw archive, which you can just extract, and what you get back is a shell script. And at the bottom of the shell script, there is a file system attached. It was gzip compressed, but that's trivial. Once I mounted it, I found that it was an ext2 file system, and it had more stuff in there, and primarily there was something called the root fs. And I figured, okay, that's interesting. It's a little Indian squash file system, and that's kind of consistent with what you would expect with a flash-based device. So I mounted that, I looked at the configuration, and I found that it had this IOOS service in reference from the Elite HTTPD config files. And I thought that this is what was the VS HTTPD implementation of. So I didn't know what else to do. I kind of went around some more. I found a shadow file. I saw the hash. I quickly threw it in John the Ripper. I felt really lit with that one because it took about a couple of days to crack it. But I didn't know what else to do with it because I didn't really have any place to use this password. Going online, I found that there was some research done on other devices from Hutu, such as the original, the Titan, and the Nano. They're all kind of similar in a way. However, I had the Elite and it didn't have Telnet anywhere on the device. And I thought, what are the chances that the vendor would actually make custom firmware for each and every one of them? It's probably all the same and they just disable Telnet on my device to make it a little more secure. And sure enough, when I did a search on the firmware, I found that it had OpenTelnet.sh script that would actually enable Telnet on the device. But I still didn't have any way to run it until I realized that I could just fake an update of the firmware and I can tell it to execute this file and enable Telnet for me. But when I tried that, even though there were no signatures and no real validation done on this firmware, for some reason it did not execute. And I didn't really know what else to do. I just kind of continued on reverse engineering. Throwing the IOOS service into IDA, I eventually found this function called checkFirmware2, which apparently does a checksum validation on the firmware that you upload. And of course, there was no signature, nothing like that, and I said, okay, well, I can just generate my own checksum. So I did that. I just put it up there, and the firmware the device was very happy to accept it. And it just executed OpenTelnet.sh for me. It said there was an error in updating the device because I did an exit once, so it automatically means that there was a problem. However, doing this action enabled Telnet, and I was able to receive a shell. I was able to execute commands and essentially do dynamic analysis, download the debugger, attach to any services, etc. So this was very happy news for me. In the course of reverse engineering, I also found that the developer thought they were writing in C++ because most of the internal state was in these structures that looked awfully like objects. There would be buffers inside, there was internal state, and it would usually be followed by function pointers right at the bottom of the structure itself. Usually there would be initialization, they would assign function pointers to the actual to the structure, and when those functions are used, every time it would pass in the pointer to the structure itself. So it is very much like this pointer in C++. So that was kind of cool. In and of itself, it's not really a problem. However, it just feels very hairy situation when you have lots of buffers and function pointers on dynamic allocation next to each other. So immediately I thought, okay, well, what kind of memory protections does it provide? I found that it had partial virtual spatial randomization. So the binary itself and the heap were at static locations. However, the libraries and the stack were randomized, so they moved around. But there was nothing else. There were no stack canaries, there was no heap protections, and of course control flow integrity would be way too advanced for this device. Alright, so then I started looking for vulnerabilities, started fuzzing. I kind of honed in on the fname parameter of the get request, because I saw that fname was actually responding to me verbatim. Whatever I put in there, it would come back inside of an XML file. So I thought, I wonder what happens there. After about 2 seconds, I found that there was a buffer overflow, and what was happening is that the developer was copying the value of the parameter into a buffer on the stack using sprintf, which is of course an unbounded copy essentially, and it just quickly overflowed, and I was able to control the return address on the stack. So I did that, and I was really excited, and I thought, man, I have this vulnerability so quickly, I can just exploit it and get execution on it, because I can control the program counter. However, what I found is that even though I can control the program counter, I couldn't point it anywhere useful. I tried pointing it to the main binary and the heap, because they were static, and I could predict those addresses. But those things were allocated on a low memory, so I had to insert a null somehow into the string. Fortunately, I couldn't do it literally, and I couldn't use sprintf's own ending null, terminator null, for this address. That's because of this format string that I was using. Then I tried to use read to libc attacks, see if I can point to some gadget, or directly to the stack, because everything was essentially executable. Those things move around, so I would have to have some sort of a information leak attack in order to actually execute it. But I decided to move on. I started fuzzing other fields. For example, the cookie field immediately overflowed for me as well. And this one was a little bit more complex. This was a heap overflow. And what was happening is that the developer allocated one of those object structures, which was called CGI tab. Inside there was a buffer of 1024 bytes. Now, in order to fill the buffer, they would take the value from the cookie and just use strcpy, which was obviously unbound, and put it in there. Immediately I thought, okay, well, if it's 1024 buffer, I will just send 1036 bytes and overwrite one of the function pointers of this structure. So I did that, and about 100 or so instructions later, this function would be used, and I was able to overflow and control the program counter by changing the function pointer of the structure, and immediately when it would jump to that location, I could have the control there. Now, I was really excited about this because there were a lot less restrictions. It was a strcpy, and there was no format to deal with. So what I did is I actually pointed it back into the heap, because that's where the value of the post messages body was being stored. And the post message body is pretty much designed for any sort of data, so I could insert pretty much any value, and I didn't have to encode my shellcode, and I just was able to gain execution that way. Alright, so now I can actually show you a demo of this. I thought, well, if I'm an attacker and I have this exploit, what is it that I can do? So this demo shows pretty much everything that we've talked up to this point. I was able to attach with a debugger, I was able to get telnet in there, and then I attached with the debugging client with GDB. So then I started looking for some coffee, I went to this website, and I thought, okay, everything's working, the device is fine. I throw the exploit, and now we kind of just let the program run. We can see it's working just fine. And then we see sort of the damage that the exploit has done to the device. So when I refresh the same website, we can see that I'm able to inject JavaScript and essentially demonstrate a man-in-the-middle attack. And the way it was done is basically execute an IP tables rules that allows me to redirect HTTP traffic to somewhere else, to some proxy that I've created. I mean, you might say, well, I mean, so what? Of course, it's HTTP, it's vulnerable, it's all in clear text. Doesn't everybody just use SSL now? Unfortunately not. I mean, according to Google's transparency report, there are still tons and tons of very popular websites such as CNN.com and BBC.co.uk that still use HTTP for a lot of portions of their website. And really, I just need one that will allow me to inject JavaScript in there in order to install keyloggers or launch browser attacks that way. So there are multiple ways to actually exploit the router and to trigger these vulnerabilities. First is you can go through the XSRF. Let's say if an attacker visits a web forum and there is some sort of request that has an fname parameter in there. Now, even though I wasn't able to exploit it for this demo, it doesn't mean that the device doesn't have any other attacks. And so if it was susceptible to other overflows through the unauthenticated GET requests, we could potentially do it without even being close to the device itself. The other option is from the external Wi-Fi. Like I said, this is a travel router. It connects to all kinds of networks with questionable cyber hygiene in there. And so there could be already vulnerable to exploitation from there. And then, of course, from inside the Wi-Fi itself, what if you connect an Android device that has malware that specifically targets the infrastructure? For example, there was one called Switcher, which would look for routers to attack from the Android device. All right, so pretty much getting to the end at this point. So this was a lot of fun. I mean, these vulnerabilities were reported to the vendor, and they were recorded in the CVE database. The Stack Overflow was very easy to fix. Just specifically use SNPrintf, which is bounded. Or in more general terms, you can use stack canaries, which wouldn't prevent the vulnerability itself, but at least it would terminate the attack vector, and you wouldn't be able to take advantage of it. The heap overflow is a little bit harder to deal with. Basically just use a bounded string copy. Or you can also, in more general terms, you can try to encode your function pointers, such as something that Windows does. But unfortunately, as you can see here, the NSA has a patent on that, so we don't get to use it. All right, so why would somebody actually try to attack travel routers or any sort of infrastructure? I mean, there are a lot of use cases for this. First one is attribution obfuscation. If I'm an attacker and I want to hide my exploits, I may want to blame someone else for it, so I can exploit their infrastructure and then use that as a jumping point for my attacks. Of course, stealing user information, authentication tokens, usernames, passwords, pretty much anything that is unencrypted, I can start collecting from this device. And then also I can manipulate the user information. You saw in a demonstration where I was able to inject JavaScript, so that means I can inject exploits, I can manipulate what they see, etc., etc. And of course, the last one is getting a foothold into other networks. It's a travel device, so it's going to be touching a lot of different networks. If I want to propagate as fast as possible, I may try to use this device to launch attacks into Airbnbs, hotels, enterprises, or what have you. So I reported this to the vendor. They were quite happy to receive it. They said, hey, thanks for finding these vulnerabilities. However, our entire product team is off on Spring Festival. I thought to myself, this is kind of cool. I want to be part of that. That sounds like fun. Then it turns out this was actually the Chinese New Year. I didn't know this, and so this was like a really cool cultural thing to learn. And of course, as soon as the Chinese New Year was over, everyone got back, and they promptly responded by sending me a patched version personally, but not to anyone else. And about a couple of weeks later, after I noticed that it wasn't published on the website, I said, hey, can you guys make this public so that people are not exploited by anyone? So they did. They just said that their release cycle was a little bit slower than it is to send me an email. So that was cool. They were super nice about it. So what did we learn from this process? I mean, the saying, don't roll your own crypto. Well, I think there should be a saying that says, don't roll your own custom CGI web server. Because those things are notoriously complex. There's a lot of work to be done, and there's a lot of parsing happening in there. And so really, either get a lot of people, get a lot of eyes, or use something that has been tested by the community. Vendors do respond. I had a pretty good experience in this case. If you can use something like OpenWRT, just because, like I said, it's been tested and used by other people. I mean, to me, exploiting routers is a lot of fun. I didn't know MIPS before this, and so it was kind of cool to learn all this process. And to be honest, I was really surprised that people still use Turk copies and sprintfs, just like they did in 1999. All right. So if you enjoyed this and you just want to chat about this, I mean, thank you for coming. It's been a real pleasure to be here. And if you have more questions, please ask ahead. And if you want to catch me in the hallways or online, you can find me there as well. I love to talk about this stuff. I will also put about 4 different articles on my blog describing all the processes I've gone through and more information about the reverse engineering at debugtrap.com. So thank you for your attention.